Hello everyone, my name is Hubert and welcome to Teach Me channel. Today we will be learning about GCSE physics, wind, solar and geothermal power sources, energy sources. Now, we have covered non-renewable energy before, and now I want to just teach you a bit about renewable energy, but I decided to split it into these, which are not water-based, and then I'll make another video next time I do physics video on water-based energy sources, renewables. Okay, so without further ado, let's get started. Now, first of all, let's start with wind power. Wind power works in the following way. I drew a terrible picture of a wind farm, and wind rotates the blades of the wind turbine, and these blades are of course connected to a turbine, which, as those blades rotate, they turn the turbine inside. So it's fairly simple how it works. And the pros of this way of getting energy is that after you make and set up the wind turbine, there is no pollution. It's literally just wind turning the blades, so there is no pollution once you set it up. There is a little bit of pollution when you make it, because obviously you need to get the steel for it, you need to transport it, you need to set it up, so that's associated with a bit of pollution. But once it's running, there is no pollution. Now, there is also no fuel costs, because obviously it's powered by wind. There is no fuel that you need to add to it, unlike, say, some non-renewable energy sources such as coal or oil. There are minimal running costs because, one, we have no fuel costs associated with it, and two is because once it's running, the only thing that you need to do is to once in a while repair something that gets damaged. You don't need to, there's no sort of workforce associated with it. You just sort of plop it down and you just leave it there until something breaks, in which case you need to fix it. So running costs are actually minimal. And there is no permanent landscape scarring. Because what I mean by this is that if we take out that wind turbine, we decide that we don't want it here anymore, we're going to take it out. If we take out that wind turbine, then there is no leftover damage. There is no leftover damage to the landscape. We can quite easily undo whatever damage to the landscape we did by putting that wind turbine. However, of course, wind turbines are not perfect. Otherwise, we would have them everywhere. But they are not perfect. One con of using wind turbines to obtain energy is that, one, they are noisy and they spoil the view. So obviously, if you put them up on the farm, then they're quite big and they break up the skyline, the horizon, and people don't like it. It tends to spoil the view and it's quite noisy, so people don't like living near them. And these two reasons are obviously a cause of a lot of frictions when an energy company wants to set up a new wind farm somewhere, but the people living in the area start protesting and start refusing to allow the energy company to build these wind farms, because obviously they have their own concerns as well. Now, another con of wind farms is high initial costs, because you need to make it, you need to transport these wind farms, which is not cheap, because you need to transport each part separately. You might have seen on highways, on motorways, you might have seen those trucks carrying those massive blades. These things are quite massive, so to set them up, it's a quite expensive endeavor. Now, they are also not flexible. They are totally purely dependent on wind. And how much wind you get, that's how much energy you get from it. There is no way to increase or decrease the amount of energy that a wind farm produces, because it's purely dictated by wind. So there is no flexibility whatsoever. And of course, what goes with that is that wind farms don't always work. If there is no wind, then this is not going to work. If a wind is blowing in a wrong direction, some older types of wind farms may no longer work. If the wind is too strong, then wind farms also work weakly because of efficiency and bunch of more complex things, the way the air travels. So those wind farms will not be running all the time, so that makes it a bit more difficult to predict how much energy you're going to get from them on a given day, because you need to predict the weather. Okay, so this is it for wind farms. Now, the next source of energy we need to cover is solar power. So, solar power works by utilizing solar cells. Solar cells are made from silicon. They're made from a silicon derivative material. They're made from a material that is based on silicon. And when the photon from light hit that silicon, this causes the movement of electrons. Now, the movement of electrons gives rise to a current, which gives rise to electric energy. So, obviously, this is more complex in detail, but long story short is that's how solar panels, solar cells work. Now, the pros of that approach is that in certain places, solar power can be very reliable because, on a whole, we are pretty good at predicting how much sun we will get in a given year. So we can predict, on a long term, we can predict how much energy we're going to get from solar panels. Also, obviously, in hot countries, in very sunny countries such as Australia, the outback in Australia, this is going to be a great source of energy, very reliable, because we will know that in most days we will have sun. Also, another pro is that there is no pollution when running. There's absolutely no pollution. It just uses sun rays and it generates electricity. So there is no pollution associated with it, similarly to wind power. Now, it is quite cost effective. We can get a lot of energy for it. We basically can get a lot of bang for our buck. Considering what it costs to make them, we do get a lot of energy from solar panels compared to the cost that it took to make them. So they pay for themselves quite nicely. Therefore, they are cost effective. And one reason for which they are cost effective is that there is almost no running costs. You can just leave them be and they will do their job. They break down very, very, very rarely. They don't need much maintenance at all. So there is almost no running costs associated with using solar panels. So that's a very, very good bonus. Now, the disadvantages of using solar panels is that, again, they're non-flexible. They depend solely on sun. If there is no sun at night, they will not make energy for you. If there is a lot of sun, you will get a lot of energy. And we have no way of increasing or reducing the amount of energy we get from solar panels. Okay, the next problem is that they require a lot of energy to manufacture. So in order to make them, you need a lot of energy. So that could be an indirect source of pollution. Because depends how you get that energy. If you get that energy required to make solar panels from a coal power station, well, then these contribute indirectly to pollution. So that's the kind of problem with using them, that they do require quite a bit of energy to be made. again, they're dependent on sun, so that sort of ties in with the non-flexible point. If there is no sun, there is no energy. If there is lots of sun, there is lots of energy. So cloudy days will make them produce less energy. They will still make energy, but they will make less. And at night, they will make hardly any energy. Now, despite their dependence on sun, they can still be quite cost-effective in countries such as Britain, where we don't get nearly as much sun as, say, we would get in Australia. So yeah, they depend on sun, but they still manage to be cost-effective. Now, and the final problem with those is that there is a high initial cost. In order to make those solar cells, it's associated with a bit of a cost because of the technology involved. Okay, so that's it for solar power. And now, the final source of power we need to discuss today is geothermal power. Now, geothermal power, the way it works is by utilizing hot rocks. One way we can get hot rocks is near a volcano. When we have a volcano filled with magma, and certain part of it is thinner, like I drew in this picture. And because it's thinner, these rocks heat up quite a bit. And now, because these rocks heat up, let's look over here. Once these rocks heat up, they release heat energy, and we can heat up a water in a container using the energy from those rocks. We can heat up a water in a container which evaporates into steam, which turns a turbine. The steam on the way up turns the turbine before it's released. And because the turbine is turned, we get electricity. So that's how we can make electricity from geothermal energy. So that's how it works. But first of all, the pros of geothermal power is that it's very reliable, because these rocks are going to be hot. We know it. Every single day when we come, we know that these rocks are going to be hot. We know how hot they're going to be. We know how much energy they release. And therefore, we can easily calculate how much energy we're going to get from a given power station. So they are incredibly reliable. Now, another advantage is that the running costs are low. Because essentially, yes, you probably will be paying for the workforce, for the people working in the power station, but there is no fuel needed. These rocks just heat themselves up using the lava from a volcano, or in some other cases, radioactive decay. So you don't need any fuel. You don't need to buy any fuel to add to heat up that water. It just heats up from those rocks. So the running costs are actually quite low. And another very good advantage, very clever advantage of this way of getting energy is that there are two ways to do it. One way I already explained, that's how we get electricity from geothermal energy. But there is another way we can use geothermal energy. We can use geothermal energy to heat up the water and then move that water directly to people's houses, to their radiators to heat their houses. So not only we can convert that thermal energy from the rocks to electricity, we can also transfer that thermal energy from the rocks to water, which we can then use to directly heat people's houses. So that's pretty cool. There are two ways we can use geothermal power. Now, the disadvantages of geothermal power is that it does require a specific location. Because it does require hot rocks, be it due to volcanoes or due to radioactive decay. The hot rocks are in very specific locations, and not every country, not every society has those locations that they can utilize to produce geothermal power. So, for example, in Iceland, there is plenty of opportunities, there's plenty of hot works, plenty of opportunities to make geothermal power, but some other places may not have those opportunities. They may not have those locations that are required. And so that's a big disadvantage. Another disadvantage is that geothermal power does require high initial costs because there is quite a bit of technology involved, and you need to build a massive power station. You need to plop down a massive power station. Often it is on expensive land, so an energy company will have to shell out a lot of money to buy that land and to build that power station on there. And because of those high initial costs, and because of the amount of energy that you actually get from this way, there is a long payoff period. So yes, you would be making a profit in this case. An energy company can make a very nice profit of this, but because of high initial costs and comparably a low amount of electricity, amount of energy generated from this way, it does take a lot of time to pay off that initial high cost, that initial high payment, that high investment. So this may be discouraging for some energy companies who may actually choose not to use geothermal power despite having an opportunity to do so because of that really long payoff period. Okay, so this is it for today. We have covered the 3 renewable energy sources that are not associated with water, which I will be making in the next video. Thank you very much for watching. I really appreciate every time you guys watch my videos. If you want to stay up to date on daily maths, science and biomedical science videos, hit that subscribe button below. And if you like this video, if you think it helped you, give me a thumbs up. If you have any question whatsoever, ask me in comments. I love answering to your questions. That's no problem whatsoever. Thank you again for watching and see you next time.